Hello students, this is Professor R. M. Mahendrakar from JSS Arts, Science and Commerce College, Gokak. Today, let us learn about what are phytochemicals, their types, and how they play an important role in maintaining the health of human beings as well as plants. Phytochemicals, this word has been derived from Greek. Phyto meaning plants and chemicals are the chemical substances. Hence, the phytochemicals are biologically active, naturally occurring chemical compounds found in plants which provide health benefits for human beings. Further, those attribute to the micronutrients and micronutrients. They protect plant from diseases and damage and contribute to the plant's color, aroma, and flavor in general. The plant chemicals that protect the plant cells from the environmental hazards such as the pollution, stress, drought, ultraviolet exposure, and pathogenic attacks are called as phytochemicals. This was defined by Gibson and co-workers in the year 1998. Recently, it is clearly known that they have roles in protection of human health when their dietary intake is significant. More than 4,000 phytochemicals have been catalogued and are classified by protective functions, physical characters, and chemical characteristics, and about 150 phytochemicals have been studied in details. The phytochemicals accumulate in different parts of the plant, such as in the roots, stem, leaves, flowers, fruits, or seeds. Means each and every part of the plant body shows the presence of the phytochemicals. Phytochemicals are known as secondary plant metabolites. They have biological properties such as antioxidant activity, antimicrobial effect, modulations of detoxification of enzymes, stimulation of immune system, decrease of platelet aggregation, and modulation of hormone metabolism and anti-cancer property. As told earlier, more than 4,000 phytochemicals have been catalogued and are classified by the protective functions. It is well known that plants produce these chemicals to protect themselves. But recent researchers demonstrate that many phytochemicals can also protect human beings against diseases. This was suggested by Narasimha Rao in the year 2003. Phytochemicals have important properties to prevent or to fight some common diseases. Many of these benefits suggest a possible role for the phytochemical in the prevention and treatment of diseases. Because of this property, many researchers have been performed to reveal the beneficial health effect of phytochemicals. Now, this is a table showing you the bioactive phytochemicals in plants. Now, the phytochemicals in plants, we classify them as non-starch polysaccharides, that is NSA, antibacterial and antifungal, antioxidants, anti-cancer, detoxing agents, and others. Now, these non-starch polysaccharides, they come under the main groups like the means they are found in this cellulose, hemicellulose, gums, mucilage, pectin, and lignin. Now, what is their biological role? The biological role of the non-starch polysaccharides are they help in the water holding capacity, delay in nutrition absorption, and binding toxins and bile acids. The antibacterial and antifungal phytochemicals, they are found as the terpenoids, alkaloids, and phenolic compounds. Now, their biological function is they help in, they act as the inhibitors of the microorganisms and reduce the risk of the fungal infection. Now, the next class is this antioxidants, and these are present in the plants in form of polyphenolic compounds, flavonoids, carotenoids, tocopherols, and ascorbic acid. Their biological role is oxygen-free radical quenching and inhibition of lipid peroxidation. Now, anti-cancer. Now, these properties are found in these carotenoids, polyphenols, curcumins, and flavonoids. And their biological role is they act as inhibitors of tumors, inhibit development of lung cancer, and anti-metastatic activity. You know what you mean by metastasis. Metastasis is a condition where the cancerous cells, they migrate throughout the body through blood. If they remain static at a place, we call it as the benign cancer. Okay, and when it starts spreading, we call it as metastasis process. So this metastatic cancer is more dangerous. Then the detoxifying agents, now these are found in the plants in form of these reductive acids, tocopherols, phenols, indoles, aromatic isothiocyanates, coumarins, flavonoids, carotenoids, retinoids, cyanates, and phytosterols. Now their biological function is they help in inhibition of the pro-carcinogens activation, they are inducers of drug binding of carcinogens, inhibitors of these thermogenesis. Now let us study about the different types of the phytochemicals we see in medicinal plants. In recent years, phytochemicals are classified as primary or secondary constituents depending upon their role in plants' metabolism. Primary constituents, generally, the phytochemical constituents of the plants fall into two categories based upon their role in basic metabolic processes, namely primary and secondary metabolites. Primary metabolites are involved in the basic life functions. Therefore, they are more or less similar in all living cells. They include the common sugars, amino acids, proteins, purines, and pyrimidines of nucleic acid, chlorophylls, etc. The secondary constituents, these are numerous chemical compounds produced by the plants through the metabolic pathways derived from the primary metabolic pathways. That is, these compounds are produced during the metabolism of the primary constituents. That is the primary main functions of the plant. That is, it may be either photosynthesis, or it may be during the respiratory processes, or it may be even during the reproductive processes, or it may be even due to excretory processes. The concept of this secondary metabolites was first defined by Albert Kossel, and he was a Nobel Prize winner for physiology in medicine in the year 1910. Later, Zapak described them as the end products. According to him, these secondary metabolites are products derived from the nitrogen metabolism by what he called it as secondary modifications, such as deamination. In the middle of the 20th century, advances of analytical techniques such as the chromatography allowed the recovery of more and more of these molecules, and this was the basis for the establishment of the discipline of phytochemistry. Some secondary metabolites, uh, examples are the alkaloids, terpenes, flavonoids, lignans, plant steroids, curcumins, saponins, phenolics, flavonoids, and glucosides. And as I told you earlier, these phytochemicals, these are found in almost all the parts of the plant body. It may be from root system to the shoot system, and in the shoot system it may be present in the stem, in the leaf, in the flower and the fruit, even in the seeds, and also in the petals, means all the floral parts also you get some of these phytochemicals. Now, among all the phytochemicals, that is the secondary metabolites, the phenolics are found in abundance in the plant. Now here, this is a pie chart showing you all the different types of the secondary metabolites that are present in the plants, and here you can see the phenolic compounds, they almost attribute to around 45%, the alkaloids 18%, then terpenoids and steroids 27%, and all other secondary metabolites to only 10%. First, let us study about the phenolic phytochemicals. Phenolic phytochemicals are the largest category of the phytochemicals and the most widely distributed in plant kingdom. The three most important group of dietary phenolics are the flavonoids, phenolic acids, and polyphenols. Phenolic compounds are hydroxyl groups containing a class of chemical compounds where the hydroxyl group is bounded directly to an aromatic hydrocarbon group. Phenolics can be classified according to their structure or biosynthetic origin. According to their structure, the phenolic are classified as simple phenols, tannins, coumarins, flavonoids, chromones and xanthones, stilbenes, lignans, etc. Now, the next group of these phytochemical, that is secondary metabolite that we see in plants, are these alkaloids. Alkaloids are organic compounds with at least one nitrogen atom in the heterocyclic ring. Its definition is problematic as they do not represent a homogeneous group of compound from any standpoint, whether chemical, biochemical, or physiological, except for the fact that they are all nitrogen containing compounds. No general definition fits all alkaloids. Alkaloids can be divided according to their basic chemical structure into different types. The following are the basic types of the alkaloids: acrinoids, aromatics, carbolines, ephedra, then ergots, imidazoles, indoles, bisenidols, indolizinides, benzamines, oxidols, quinolines, quinozolines, etc. Alkaloids demonstrate a diverse array of the pharmacological actions, including analgesic, local anesthesia, cardiac stimulation, respiratory stimulation and relaxation, vasoconstrictions, muscular reactions and toxicity, as well as anti-neoplastics, hypertensive and hypotensive properties. The next groups are these saponins. Saponins are compounds that possess a polycyclic agalcone moiety with either a steroid, so it will be a steroidal saponin, or tritetrapenoid, then we call it as the tritetrapenoid saponins, attached to a carbohydrate unit, a monosaccharide or a oligosaccharide chain. These sugar units are composed variously of the pentose sugars, hexosugars, or uronic acids. This hydrophilic asymmetry means that these compounds have the ability to lower surface tension and soap-like. They form foam in aqueous solution and cause hemolysis of blood erythrocytes in vitro. The agalocone portion of the saponin molecule is called the genin or sapogenin. These saponins are widespread among plants, having been reported for more than 500 plants and at least 90 different families. These substances have been isolated from all parts of the plant, that is, leaves, stem, roots, bulbs, flowers, and fruits. Although they tend to be concentrated in the root of many species, such as this Digitalis purpurea, Dioscorea villosa, Gentinia lutea, Glyriza species, and the ginseng species. The next class are these terpenes. Terpenes are the largest and most diverse group of plant secondary compounds. The name terpene is derived from the word turpentine, which in turn comes from the old French literature meaning resin. They are derived chemically from 5-carbon isoprene units assembled in different ways. Terpenes are classified according to the number of these isoprenes unit in the molecule. A prefix in the name indicates the number of the terpene units as follows. Like these hemiterpenes. Now these are a group of these terpenes that contain only a single isoprene unit. For example, the isovaleric acid from this vaccinium, okay, are these hemi terpenoids. The next is monoterpenes. The monoterpenes contain two isoprene units and have the molecular formula C10H16. They are important component of plant essential oils or volatile oils. Monoterpenes tend to occur in members of certain plant families such as these Lamiaceae, Pinaceae, Rutaceae, then Apiaceae, from which many essential oils are commercially produced. A series of monoterpene glycosides appear to have this vasodilation effect on coronary vessels and the femoral vascular bed. The next is this sesquiterpenes. These type of terpenes contain 3 isoprene units and have the molecular formula C15H24. A number of sesquiterpenes, like these lactones, show antibacterial, antifungal, and antiprotozoan activities. The next are these diterpenes. These are the terpene compounds that are composed of 4 isoprene units and have the molecular formula C20H32. They are used in herbal medicine as the diaphoretic and anti-rheumatics. The next are these sesquiterpenes. Sesquiterpenes have 25 carbon atoms and have 5 isoprene units. An example for this sesquiterpenes is this geranyl fasonyl isolated from the seed oil of this camellia and Camellia japonica, which belong to the family Thiaceae. The next is this triterpenes. These consist of 6 isoprene units and have the molecular formula C30H48. Quasinoids are isolated from this Quasina amara. These are degraded and rearranged products of these triterpenes. Quassia is used as a bitter tonic, as an insecticide, and as an enema for the expulsion of the threadworms. The next are these sesquiterpenes. They have 7 isoprene units. Then tetraterpenes, they have these 8 isoprenes, as well as the polyterpenes, which have got a long chain of many isoprene units. Now the next group is this lipids. Lipid comprises a group of naturally occurring molecules that include fixed oils, waxes, essential oils, sterols, fat-soluble vitamins such as the vitamin A, D, E, and K, phospholipids, and other. Lipids serve various biological actions as major structural component of all biological membranes and as energy reservoirs and fuel for cellular activity, in addition to being vitamins and hormones. Although lipids are considered as the primary plant metabolites, recent studies have revealed the pharmacological activities of membranes of this class of phytochemicals. Uh, the lipids are of different types. Now, for example, the fixed oils. Fixed oils constitute of high molecular aliphatic long-chain fatty acids such as the palmitic, stearic, and oleic acid esterified with glycerol. The fixed oils of the flax seeds are potent antioxidants and anti-inflammatory. They are used as the prophylactic to decrease the risk of the arteriosclerosis and cardiovascular diseases. The next class of these lipids are these waxes. Waxes are the lipoidal matter constituting mainly from long aliphatic chains that may contain one or more functional groups. The jojoba wax has this anti-inflammatory, anti-aging, and wound healing activities, and hence it can be utilized in several skin conditions. The third group of lipids are these essential oils. Essential oils are volatile, aromatic, complex mixtures of relatively low molecular weight compounds. They have many and important medicinal uses such as antiseptic, antimicrobial, analgesic, sedatives, anti-inflammatory, spasmolytic, and local anesthetic remedies. These are also used as fragrance in embalmment and in food preservation. So with all this information, we can come to a conclusion that there are several classes of secondary plant metabolites that are responsible for the biological activity of herbal medicines. The use of herbal medicine should be based on comprehensive phytochemical studies for the determination of the chemical constituents of the herbs involved. Hence, the knowledge of the resultant pharmacological and toxicological effect can be deduced, and also the synergistic and the antagonistic effect due to the use of multiple component herbal formulae can be deduced. For this reason, the isolation and structural elucidation of the secondary plant metabolites is still a huge and fast-growing approach, and the techniques used for separation and analysis are advancing continuously. With this, we conclude this topic on the phytochemicals in herbal plants. So thank you for your time. Please take care of your health and follow all the COVID norms. Thank you.